Good morning, all. So, in the last class, we had started with what is software requirement specification, and I had also told you what is the structure of writing that software requirement specification. So, we saw that there is one way of writing that black book, that is natural language. The language in which we can speak naturally is considered as a requirement there. But there are some disadvantages of writing that SRS in the natural language. Okay. So there are some alternatives of writing that black book. So those alternatives we will see one by one today. See, the first alternative is a structured natural language. Second is design description language. Third is graphical notation and mathematical specification. So these are different ways or alternatives to natural language specification for writing the software requirement document. So this question is rarely asked. They may ask you this question for 5 marks, saying that what are the alternatives to natural language. Okay, so we will see one by one. So first alternative way of writing that black book is structured language. Okay. So what is structured language? Structured is nothing but there is one specific format. Okay. Structured is nothing but what? We have a specific format of writing the document. So we have to follow a specific way of writing the document, such as uh, there are limited. Okay. See, requirements writer is limited, so you cannot write or just write whatever you want in that document. The requirements are limited there. It means you have to write according to the template which is predefined. So we have one format. Okay, we have one specific format saying 1 2 3 4 and 5. So according to that format only you have to write those requirements in that black book. Okay, so those are written in a standard way. Standard way means some rules and regulations are followed to write those requirements into that black book. Okay, the terminology used in the description may be limited. So the categorization of requirements, whatever is done, that is also limited. Okay, so the main advantage of using this structured language specification is that most of the expressiveness of natural language is maintained. It means most of the content from the natural language is converted into standard format. Are you getting that? So number of sentences or number of the data is reduced. Only standard data is being considered in this structured language format. Okay. What is another thing? A degree of uniformity is also observed in this specification. Uniformity means what? What do you mean by uniformity? Same. Every requirement is of same type. You cannot have all different type of requirements, connected requirements. Okay. So there is only one type of set of requirement. All right. Suppose if I say fruits, this is a criteria. Here I can only include the fruits. I cannot include flowers, vegetables or any another things. I have to only include what? Fruits. So when I say the requirement for transaction of deposit, only the information related to the transaction deposit must be included. That is called as degree of uniformity. Okay. So these things just you can highlight in structured language specification. So this is one of the alternative way, okay, of writing the requirement. Then more standard way, okay, there is one more standard way of writing the requirement. So what is that more standard way? So that is called as form based specification. So all of you know that what is a form, isn't it? So form, whenever I say form, okay, so what are the things? There is a thing called as what? Label. So I have something which is called as label. okay, then I may have any of the components. So this component may be a text box, this component may be a button, this component may be a drop down list, this component may be a text area, this component may be a hyperlink, anything. So a form may include all the components. So this is also one of the way of including the information into that black book. Okay, so this is also one method of writing or expressing the requirement into that black book. Okay, so what all things you can include, okay, in this black book? So we have to define the function or entity. So entities are nothing but what the main components of your project. Suppose you have an ATM project, what are the entities here? The entities here are login, okay, then you have transaction, which is going to perform deposit and withdrawal. Okay, we have customer details. So all these are called as entity. So in form-based specification, more standard approach is followed, okay, to maintain the documentation. So that more standard way is nothing but defining the functionality or identifying the entities of your software or project. All right. Next is description of inputs. Okay, so it will also define what are the main inputs of your project and where they come from. Okay, so from where you are providing those inputs. It will also include the details of output and where they go to. So what are the basic outputs of your project or the components of your project, and from where the inputs are coming and where the outputs are going. So all such information is represented in the form-based specification. So indication of other entities required, it means we have to identify all the entities of your software. Pre and post conditions if appropriate, okay. So you have to identify what is going to happen first before providing the inputs, and what is going to happen after providing the inputs, and what will be the outputs that are generated, and how those inputs and outputs are handled, right? And it is also going to tell us if there are any errors that can be generated from this function, or if there are any bugs or defects that can be generated from this function, and how they can be handled, right? So this is one more way of writing the document. So this is one more alternative way of writing that standard requirement, okay, that is standard document specification. All right. So we will see one example for form-based specification, how these form-based specifications are written. All right. So we have seen one software, that is insulin pump control. Hardware is there, and that hardware is going to calculate your blood sugar level. And depending on the blood sugar level, the microcontroller has to calculate the dose, and then that is given to the patient, right? So this is an example of form number 3.3.2. So we have some components in that system. So insulin pump control software is a software, and this is an example of the SRS, that is form based write-up of the information into your black book. And 3.3.2 is nothing but what? This is the third component under that third activity, under that second activity. That is the reason it is given as 3.3.2. All right. So what is the main function here? So main function that I want to categorize is I have to calculate the insulin dose. Okay. So what is the function here? The function is to calculate the insulin dose. And how you have to calculate that? It should be a safe, right? So whatever dose you are going to calculate, it should have, okay, a safe sugar level. So whatever you are going to include, that should be safe sugar level, right? So description is nothing but what? The detail about this function. So what is the detailing of the function? You have to compute the dose of insulin to be delivered, right? So what you have to do, we have to calculate the dose of insulin, right? When it has to be delivered, okay? So how you have to calculate that? You have to calculate, okay? See, it should be delivered when the current measured sugar level is safe, okay? So you have to first calculate the dose and measure the sugar level, right? and it should be in the safe zone between 3 and 7 units. All right. So safe sugar level is nothing but what? The sugar level which is between 3 and 7 units. It means this is our safe zone, 3 and 7 units, okay, of dosage. We can only give uh, dosage at a time of 3 to 7 units, okay. So this is the dosage capacity. You can only give that amount of dose, right? Now, what are the inputs to calculate this dose? What are the inputs to calculate this dose? Current sugar reading. Okay. See, for example, the sugar level has started from morning. So you are calculating that sugar level from morning. Okay. So the previous two readings are R0 and R1. Okay. It means, for example, R0 is taken at morning 6 a.m. and R1 is taken as at for example 10 a.m. Let us take a gap of 3 to 4 hours for each reading, right? Now I have to give the next dose. Okay, so after 10 o'clock, if you consider the 4 hours, that is 11, 12, 1 and 2. So now I have to give another dose at 2 p.m. to the patient, isn't it? Now that will be called as a current sugar reading. So R2 is the reading which is taken after a gap of 4 hours, that is at 2 p.m. So R0, you can take R0 at 6 a.m. Okay, R1 which is taken at 10 a.m. Okay, and R2 which is taken at 2 p.m. Are you getting that? Okay. Yeah, so these are my three inputs for the day. See, the number of dose depends upon the sugar level of the patient. Okay, it may be 2 times a day or it may be 3 times a day, not more than that. Okay, I think that see, it is given safe zone is between 3 to 7 units. It means 3 to 7 units can be given to the patient depending upon his condition. All right. Okay. Now, after taking these inputs, what you are going to do? Source. What is the source here? Current sugar reading from the sensor. So current sugar reading is nothing but the reading which is taken at 2 p.m. and other readings from the memory. So these are your other readings. That is R0 and R1. These readings are already maintained into that memory of insulin pump control hardware. Okay, and that is maintained with the help of this software. Details are maintained with the help of microcontroller. So by taking these data, which data you are going to take? We are going to take two data here. So the first data is current sugar level of the patient, for which has to be given at 2 p.m. and then the readings which are done at 6 a.m. and 10 a.m. So after taking that, what will be the output? The output is that the insulin pump control software has to compose the dose. Okay, so this dose is nothing but the insulin that has to be delivered to the patient. Okay, so after taking R1, see, it means that when you want to give the insulin to the patient, to calculate that dose, every time you are referring the details, sugar level details taken previously. So every time the sugar level is checked with the previous level, and then only the dose is calculated, right? See, this is the functional way of representing the data or the requirements. This is the more detailed way, which is in the format. Okay, so this is one of the way of representing the data into your SRS, right? Now, after this, what you are going to do, it is going to go into that control loop. So if you go back to the slides of insulin pump control software, there you will come to know how does that insulin pump control software works, where I have shown you a video. I have also shown you a diagram to indicate how, from where the data will come and where the data will go, what are the activities carried out in that hardware. You can refer that diagram here, okay, main control loop. So this loop is repeated until the dose is given to the patient, okay. So how it is repeated? By taking the previous readings, okay, and by taking the current readings. So some calculations are made, right? Now, this is very, very important. Action is nothing but what? We have to trigger the insulin here. It means it is the main activity of that software, where depending on the calculations, the dose must be given to the patient. It means, for example, if your percentage is above 75 and less than 100 in the PG level, it is considered as distinction. If your percentage is 74 also, it is not considered as distinction. But a minor mistake in the software may create a lot of problems. It is like that. So the action is nothing but these are all preconditions and post conditions, and the code depending on which the insulin is given to the patient, which is very, very risky. Okay. So let me tell you one by one. Okay. First is composed dose is zero if the sugar level is zero. It means if the sugar level is zero, then you should not give any dose to the patient. If the sugar level that is calculated recently, that is normal, okay, or it is like not increasing, then you should not give any dose to the patient. All right. Next. So I will tell you the next one. See, or is another condition here, okay? Or falling, or if the level, okay, or uh, it is telling, see, let me highlight the related part only so that it becomes easy to understand. If the sugar level is falling, or, okay, if the level is increasing, the sugar level is falling, it means R2 is less than or not an R1. Okay, R2 is less than or not an R1. Okay, and see, the rate of increase is decreasing. It means you can see that R0 was more, R0 is having a sugar level first level, R1 is less than R0 and R2 is even less than R1 and R0. At that situation also, if you see that the sugar level is falling constantly, then there is also no need to give the dose to the patient. Are you getting that? Okay. See, this type of calculations are very, very important. This is just like an algorithm only. Okay. If the sugar level is increasing, okay, and the rate of increase is increasing, it means R0 is one sugar level, R1 is increased, then R0, R2 has also increased, then R0 and R1, then obviously you have to give the dose to the patient. Okay, then how that dose is given to the patient there? So if you find that there is constantly increase, okay, if you found that there is constantly increase, then composed dose is computed. You have to calculate the new dose, that is R2. So how you are going to calculate that R2? You are going to divide the difference between the current sugar level, that is R2. Okay, now how you are going to calculate? You are going to calculate the difference first, that from current sugar level, that is R2, and the previous levels. Okay, so first you are going to calculate the difference, and then you are going to divide that difference by 4, right? So first you are going to take the current reading, then you are going to find the difference from the previous levels, and then you are going to divide that by 4 and then rounding the result. It means in this is a formula which is used to calculate the amount of dose that has to be given to the patient. Are you getting that? All right. Okay. So if the result is rounded to 0, if again you find that the result is rounded to 0, it means after calculating all these things, if you see the result is 0, then the dose which is given is minimum dose to the patient. So minimum dose is one dose. For example, some people are having a BP problem. So every day they will take a minimum dose. That dose is not increased also, that dose is not decreased also. That is just a precaution to maintain the BP. Same way, if the patient is having a stable sugar level, then the default dose is given to the patient. Are you getting that? So see, this is very, very important. So this will tell you how exactly the doses are calculated. But again, you see that this is again, okay, so this is a form based and we can understand that. But here you can see that this can be written in a more easy way by using some symbols like greater than, less than, or some operators, isn't it? We can also write this precisely. We can also make it more clear. Okay, so that is made clear in again the next format of writing the SRS. Okay, yeah. So this is one example of writing the SRS by using form based specification. It means you're going to write the requirements using form based. All right. Okay. So what are the requirements here? Two previous readings so that the rate of change of sugar level can be computed. We need R0 and R1 to calculate R2. If you want to calculate R3, we need R0, R1, R2. Okay, so that is in that way. So what are the preconditions? The insulin reservoir contains at least the maximum allowed single dose of insulin. It means you have to set the insulin to maximum dose, that is 3 to 7 units. Okay, this is minimum and 7 is the maximum dose. It should be ready. Okay, so you cannot give above 7 units. It is one example here. Okay, so technically the doctor will tell you the amount of dosage. R0 is replaced by R1, R1 is replaced by R2, isn't it? Yes, if I want to calculate R3, so it will depend upon its previous, that is R2, R1 and R0. In this way, all the readings, maximum readings are maintained into the memory and are referred for every new dose. So we don't have any side effects for this software. Okay. So in this way, the data is categorized into form based. You have to write function, description, input, sources, outputs, destination where the main actions are going to be performed, then what are the requirements, preconditions, post conditions, and what will be the side effects. All right, yeah. So the first way of writing is natural language, though it has some disadvantages, so we go for structured language specification. Okay, then after that we move for form based specification, right? So this is one example to understand the form based specification, right? Then we go for another format that is called as a tabular representation or tabular specification, right? So it is also one of the alternative for natural language. Okay, yeah, it is used to define a number of possible alternative courses of actions. As I told you, considering this, which is a form based node specification, you can see that this can be written more easily by using a tabular format. So this kind of conditions, rather than writing in a paragraph, see, it is very difficult to understand the conditions here. So we can refer one format. That format is called as a tabular specification. So you can see more clearly here. I have this as a condition and what is the action, isn't it? This is more easy to refer than this. Okay, so even this format is used, but still if we take this, it becomes very, very easy to understand. So what is the first condition? If sugar level falling, it means you can see that R2 is less than R1. It means the sugar level is falling down. Then the dose is 0. Okay. If you can see the sugar level is stable, it means if R2 is equal to R1, okay, and R1 was also equals to R0, then also the dosage that is given to the patient will be 0. So these are nothing but what conditions you saw here, what I have explained to you. Those are written in the tabular condition and action format. Okay. Now, one more third condition, if sugar level is increasing, the sugar level is increasing, okay, and the rate of increase is decreasing, it means you saw that, the sugar level in R2 is increasing, okay, yeah, but R1 is decreased, then R0. It means you can see that sometimes it is increasing and sometimes it is decreasing. At that time, you have to calculate the differences, and then there is no need to give the uh, composed dose. Okay, here the default dose is given to the patient. Sometimes the default dose is given to the patient. Okay, so where the dose is to be calculated, see, if the sugar level is also increasing and the rate of increase is also increasing. It means the sugar level is increasing at every reading at R0, R1, R2 and R2. It is increasing constantly at each level. Then this is the formula which is used. Okay. So this is the formula R2 minus R1 divided by 4. This is the basic formula, and then it is rounded. Okay. And then it is rounded and that amount of dose is given to the patient. In case if the rounded dose is also equals to 0, then minimum dose, which is the default dose, and that is given to the patient. Okay, right. So see guys, this example is very important. They may ask you the question, what are the alternatives of writing the SRS rather than the natural language. So first question, they may ask you explanation of SRS for 10 marks, alternatives of natural specification in SRS. Okay, they may ask you this for 5 marks, right? Yeah. So the
Hello, ma'am.
next way is graphical model. You know very well, graphical models are very
Ma'am,
interesting. Yes. Any queries?
ma'am,
Yes,
ma'am,
yes.
I'm not getting anything from that example.
Which example?
Ma'am,
This
I'm
one?
not getting.
Which one? This
Yeah,
one?
ma'am. Yeah, ma'am.
Okay, you're not getting it. Getting in
I
the
am
sense.
not getting any link in between your explanation and the notes.
No, no, see. For that, you have to first go for
I'm
insulin pump control
student.
software. Okay. So you have to first go for this one, insulin pump control software. Okay, you have to study how that software is going to work. First thing. Okay.